Hello students to my channel The Physics, and you must say wow, what a concept. So this is the second day, the numerical king day 2, and as I say all the numericals we solved, that is from the first day. It is 1 to 15, and today we solve 16 to 20. And all the numericals here given are today's numericals basically, and this is based on the superposition principle, and we all know what is superposition principle. And from Coulomb's law, we know that if we calculate a net force on a particular charge, then due to the different charges, due to many more charges, then we must take a vectorial sum of all the forces that individually act on that particular forces. So you have to, since force is a vector quantity, then you have add all the uh, forces vectorically, not algebraically. So let's start with the question number 16. So students, just see the numericals. Numerical 16, uh, 3 equal charges, that is 2.0 into 10 to the power minus 16 coulomb each. There are 3 charges and are held fixed at the 3 corners of an equilateral triangle of side 5 centimeters. So let's draw a triangle. Let's say AC Verma 16, this is AC Verma 16, and this is the triangle, and there are in each corner 2.0 into 10 to the minus 16, that is microcoulomb. 2 microcoulomb charges are given at the 3 corners, and this is uh, the distance, the sides is here given is 5 centimeter, and we have to calculate coulomb force experienced by one of the charges due to the rest one. So uh, if we calculate at position B, here A and B, and this is C. So the charge particle at B, so C apply a repulsion force along these directions, and if we name this is BC, so the force experienced by B due to C, and this one is if B due to A. And this, since this is equilateral triangle, so the each angle is 60 degree, each angle is 60 degree, and this is also 60 degree. And so F equal to, so F BA, so F BA equal to, we know that from Coulomb's law, the force is 1 by 4 pi epsilon naught, 4 pi epsilon naught into Q1. Q1 means 2 into 0 into 10 to the power minus 6 into 2.0 into 10 to the power minus 6 divided by divided by r square, that is here 5 centimeters, so 5 by 100 whole square. So 5 by 100 whole square, that is 1 by 4 pi epsilon, and this value is 9 into 10 to the power 9. 9 into 10 to the power 9 into 2 to the 4 into 10 to the power 6, 6 minus 12 by 5 5 is 25 by 100. 100 square means if this is in uh, order of magnitude, then we can write 100 into 100 means 10 to the power 4. So this is the amount of force, this is the amount of force, and this is equal to 36 by 25, 36 by 25 into 10 to the power of 9, 1, 10 10. uh, 10 to the power of 13 minus 12, that is 10. So 36, so 36 by 25 into 10, that is, if we cancel each other, the 5 2s are 10 and 5 5s are 25. So 36 by into 2 by 5, 36 by 2 into 5, and this is so this is FBA, this Newton is FBA. Similarly, if we calculate similarly if BC, FBC, and this is equal to 36 into 2 by 5. Why? Because these and these force, because these and these force and these force and two are equal, since the charges and the distance are also equal. So if we take this one, if we take this force as x, suppose let, then the resultant force F equal to F BA whole square plus FBC whole square plus 2 FBA into FBC. So x square, and this will be square, so x square plus 2 into x into cos theta. Here cos theta equal to cos 60 degree. So x square 2x square plus 2x square into cos 60 means 1 by 2. So 2 cancel each other, and 3x square, that is f square equal to 3x square, or f equal to, or f square equal to 3x square, or f equal to root 3 into x equal to root 3 into 36 into 2 by 5, because this one is this Newton. So the resultant force is this Newton, or we can calculate this one as you also multiply it this factor and get the result. Is that clear? And this is superposition principle, that when the three charges are in the three vertices, and you have to calculate the resultant force, so the resultant force goes through these directions. Since the two forces are equal, so it makes 30 degree. So the magnitude of force is this one. So magnitude of this force is root 3 into 36 into 2 by 5, and we can also multiply it and simplify it also. 5 7 35.2, so 2 2 is 4, so 2 2 is 4, 14.4 into root 3. So 14.4 into root 3, or we can also simplify it, root 3 equal to 1.732, and multiply it 14 by, we get a number. So that is 14.4 into root 3 Newton, and you calculate it. So this is completed. This numericals is completed, that is HC Verma 16. So the next question is 17, and here the question is given 4 equal charges 2.0 into 10 to the power minus 6 coulomb, and each coulomb is the charge of unit of charge, and each are fixed at the four corners of the square of side 5 centimeter, and find the coulomb force experienced by one of the charges due to the rest 3 1. So the questions is same as it is 16, and here this is square is given. So HC Verma 16, and the next one is 17. So HC Verma 17, this one, and here there is a square, there is a square, and a charge of 2.0 into 10 to the power minus 6 coulomb are given at each vertices, and the side is 5 centimeter. So this one we take charge q, and this is x, the distance is x, so the diagonal is root 2x. Since this is x, so it is the hypotenuse, so hypotenuse square equal to this one is x, so x square plus x square, or 2x square. So hypotenuse equal to root 2 into x, so this is the hypotenuse. And then if we calculate the forces due to these three forces on that particular forces, then these force act along these directions, repel along this direction. So this repulsion force F equal to 1 by 4 pi epsilon naught. This is the proportionality constant. And q into q means q square by x square, and let it be suppose y let. And again these along that particular point, and this force also acts along these directions, and the value is y, since the distance between the distance between these two charges is also equal to between the two charges, so this is y, and the angle between them is this one, so the resultant of these and these forces will be, so this is, if f dash is the resultant force, then f dash equal to root under of f square plus 2ff cos 90 degree. So cos 90 equal to 0, then root under of f square 2f square means f root 2. So f root 2 is the resultant force. Is the resultant force between these and these charge particle, and the another charge is given here. So these charge also exert a particular force along this direction, and so the resultant force, if this force is f double dash, then f double dash equal to k, this is the proportionality constant, and k q into q, that is q square by root 2x whole square, so there is q square by root 2 means 2 into x square, so 2 into x square. Here f equals to k q square by x square equal to y, so k q square by x square equal to y, that y by 2, this is y by 2. So the resultant force for calculations of this resultant force, and this is must be 45 degrees, so the direction is 45, but the resultant force f equal to f dash plus f double dash. F dash means this force, that is the resultant between these and these forces, and f double dash is the particular force, so we have to add this and this one, that is f dash plus f double dash. So f dash equal to f root 2 plus f double dash means y by 2. F root 2 means y root 2, y, f equals to y, so f root 2 means y root 2. So y root 2 plus y by 2, that is y, you can take common, and this is equal to half. So y equal to k means 9 into 10 to the power 9, so 9 into 10 to the power 9, y k q1 q2 means 2.0 into 10 to the minus 6, and this is a square, k q square by x square, x means 5 by 100, since it is 5 centimeter, so this one square into root 2 plus half, and we can calculate it easily and get 27.5. So 25.5 Newton forces, that is 25 Newton forces, that is F equal to and this one f dash plus f double dash, f dash plus f double dash, and if we add these and these forces and along this a particular direction, there is 45 degree. So summarize these numericals as you have to calculate electrostatic repulsion force along that particular charges due to these and these, due to the three other charges. So this is equal to first of all we have to calculate these and these force that is along these directions, and next one you have to add with that particular forces. So the resultant force is 27.5 Newton along 45 degree, along 45 degree. So this one is completed. Okay, so students, the next numericals is question number 18, and isn't clear? Yes. So the question is that a hydrogen atom contains one proton. One proton means 1.6 into 10 to the power minus 19 coulomb. Yes, and one electron. Also, so the charge is same, electron and proton, and the distance between them. The electron revolves at a circular. Yes, all the electrons are revolving in a particular orbit, Bohr's orbit, and this is first Bohr orbit of high radius 0.53 angstrom equal to 10 to the minus 10 meter, and with the proton at the center. Yes, and the hydrogen atom is said to be in the ground state. In this case, find the magnitude of the electric force between the proton and the electron of the hydrogen atom in its ground state. Yes, find the magnitude of electric field between the proton and electron. So it is too much easy questions, and if we consider, so H.C. Verma, electrostatics, electric field and potential, and this is question number 18. So H.C. Verma 18, electric field and potential, electric field and potential, electrostatics, volume 2. So H.C. Verma 18, and here a positive charge is given and an electron in the ground state. So here an electron is revolving, and that particular distance is 0.53 angstrom. 0.53 angstrom, that is equal to 0.53 into 10 to the power minus 10 meter, into 10 to the minus 10 meter. 0.53 into 10 to the power minus 10 meter. Yes, it is given. So the charge of an electron, that is Q equal to, we know that 1.6, and from quantization of charge we know that, and this is the least value of electronic charge that possesses an electron as well as a proton. So 1.6 into 10 to the minus 19, and so the force equal to, according to Coulomb's law, the attractional force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So K is the proportionality constant and the distance is R. So F equal to K Q1 Q2 R square. Here K equal to 9 into 10 to the power 9 into 1.6 into 10 to the minus 19 into 1.6 into 10 to the power minus 19 divided by R square. So it is R square is 0.53 into 10 to minus 10 whole square. So students, I want to say, for study and for clearing this type of concepts clearly, there is no record of board and versatile setup just write down the numericals and try to clear it. So this is the series name Numerical King Day 2, and this is Day 2 obviously, and we discuss the numericals of electrostatics from AC Verma, electric field and potential from 16 to 20. I think that it is clear to you. So the answer is you have calculated, I think, 9 into 10 to the power 9. So for easiest calculation, you take 9 into 1.6 into 1.6 by 0.53 whole square. First, this type of numericals, when it is critical for those for competitive exams, there is no allowed of calculators, so you have to calculate at first as the numerical value is put aside, and all the magnitude into the 9 minus 19 minus 19, or this is here the below, that is denominator portions is 10 to the minus 10, so 10 to the power minus 10, so 10 to the power minus 10 square means 10 to the minus 20, and when it is in the numerator position, there is plus 20. So the answer is minus 19, 19, 28, there is minus 10, so 8.2 into 10 to the power minus 8 Newton. So this is the answer, 8.2 into 10 minus 8 Newton, and it is I think it is the base level numericals, and that is Coulomb's law, F equal to K Q1 Q2 by R square. So here then for clearing the numericals, you have to take the assumption that positive and negative charges are equal in magnitude in the sense of charge. So that is 1.6 into 10 to the minus 19, and the distance is 0.53 angstrom, and so you have to calculate it, transfer it in SI unit, that is 0.53 into 10 to the minus 10 meter, and then you calculate the forces, that is F equal to 8.2 into 10 to the minus 8 Newton. And so look at the next numericals, that is question number 19. Question number 19. Yes, the 19 number question is, find the speed of the electron. Find the speed of the electron. Find the speed of the electron in the ground state of a hydrogen atom. The description of ground state is given in the previous problem. So description, what is ground state? That is the first excited state. It is not first excited state, it is ground state. So find the speed of the electron. So if we take the numericals, the electron are moving along this particular directions with the speed v, then the centripetal force F equal to mv square by r. This is the centripetal force. And what is centripetal force? And we clear your concepts from the 11th level. There is a circular motion, and here it is given that Fc equal to mv. What is centripetal force? When when every body moves in a particular circular path, then it requires a force, that is centripetal force, and it acts along that particular direction. This is central in nature. So this force here, this central in nature, there is central force or centripetal force is provided by the Coulombian attractional force. So we can equal these forces with the particular forces. So question number 19, it is so easy, ACV 19. So mv square by r, this is equal to force, that is 8.2 into 10 to the power minus 8, 8.2 into 10 to the minus 8, and this force. So here you have to calculate the velocity with which this particle move. The velocity here, the velocity v square equal to 8.2 into 10 to the power minus 8 into r is the radius, divided by m. This is means 8.2 into 10 to the power minus 8 into r means 0.5 angstrom. That is 10 to the minus 10 divided by mass of the electron is 9.1 into 10 to the minus 31. That is v square equal to this, or if we calculate the value of v, then it will be 2.18 into 10 to the power 6, and the calculation is same as the previous one. So 2.18 into 10 to the power 6 meter per second. This is the answer, and this is the answer. So it is completed. AC 19. And is a special. The difference is that from 18 to 19 is here applied the centripetal force is equal to the Coulombian force. The centripetal force for centripetal force means mv square by r, and you have to equal to kappa, that is constant, into q1 q2 by r square. And this is Coulombian attractional force is equal to the centripetal force. Means when a particle moves in a circular path, then the centripetal force here only the centripetal force is provided by the Coulombian attractional force. So you have to equal this one or calculate the velocity. So the 17 number question is 16 number question is based on the superposition principle, and it is taken. So 16 number question is based on the superposition principle, and 17 is also based on the superposition principle. Here the difference is the first one is the triangle and the second one is a square. And for the 18 it is so simple questions, that is it is applied from Coulombian attractional force F equal to kq1 q2 by r square, and the 19 number is based on the centripetal force. Number 20. 20 number question, it is a little bit tricky question. So question is 10 positively charged. Yes, this is 10 positively charged particles are kept fixed on the x-axis at position x equal to 10, 20. Oh yes, 10, then 20, then 30, then 40, then 50, then 60, then 70, 80, 90, 100. Yes. So there are 10 charges at a particular intervals, and the first particle has a charge of 1 into 10 to the power minus 8 coulomb. 10 to the power minus 8 coulomb, 1.0 into 10 to the minus 8 coulomb, and the second is 8 into 10 to the minus 8, and the third is 27 into this one, and so on. And the 10th particle, and the 10th particle has a charge 1000. Find the magnitude of the electric force acting on 1 coulomb charge placed at the origin. So yes, there are 10 charge particles. AC Verma. So this is AC Verma 20. This is the last question. AC Verma 20. And there are 1 coulomb charge at the origin, and this is the origin. I think this is the origin. So at origin there is a 1 coulomb charge, and if we take 10 centimeter, then 10, then 10, then 10, then 10, dot 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 dot, this is 1000. So here a charge is given, that is 1.0 into 10 to the power minus 8 coulomb. One is if there is a problem, then you can pause the numericals, that will be better, and the question is written then and see the answer. So it will be the better way to realize all the questions and answer as well. So 1 coulomb is charged at the origin, and there is a charge 1.0 into 10 to the minus 8 coulomb here, and the next one is 8 into 10 to the power minus 8 into 10 to the power minus 8 coulomb, and then 27, then 27 into 10 to the power minus 8 coulomb, then this one, and the last one is 1000, and the last one is 1000 into 10 to the power minus 8 coulomb. Last one is 1000 into 10 to the minus. All the charged particles, we see that all the charged particles are kept at a particular intervals. So first of all, and this is 10 centimeter. This is 10 centimeter. So first of all calculate the first one, that is the force between this and this one, force between this and this one. So F equal to F1, if we say F1, then F1 equal to 1 by 4 pi epsilon naught, that is 9 into 10 to the power 9 into Q1. Q1 that is 1 coulomb into Q2 means 1.0 into 10 to the minus 8 coulomb. Q1 Q2 by R square, and this is 10 centimeter, so 10 by 100 whole square centimeter. Then you have to divided it with 100, and that is centimeter. So 0 0 cancel each other. So 9 into 10 to the power 9 into 10 to the power minus 8 or 9, so 10 into this 10 square, that means 100, and it is on the numerator position. So 9 into 10 to the power of 3, or this is 9, so 6, 9 into 10 to the power 6, is it correct or not? So 9 into 10 to the power 6, there is a charge of 1 coulomb, and there is 1.0 into 10 to the minus 8 coulomb. So 9 into 10 to the power 9, there is the value of kappa into Q1 Q2. Q1 Q2 by R square, the distance is 10 centimeters, so 10 by 100 whole square. This 0 0 cancel each other, and 10 square means 100. 9 into 10 to the power 9 into 10 to the power of minus 8. Yes, this is mistake. 10 to the power minus 8. So 9 into 10 to the power 9. So 9 into 10 to the power 9 into 10 to the power minus 8 into 100 into this is 100. So the value is 9 into 9 into 10. So the value is 9 into 10. Yes, the first value of the charge is 1.0 into 10 to the minus 8 coulomb. Yes, so this is this Newton. No, 8 minus 10, so 1000. So 9 into 10 to the 3. Yes, 9 into 10 to the 3 Newton. Yes, if we calculate the second one, that is F2. If we calculate the second one, that is F2, then F2 equal to similarly 1 by 4 pi epsilon naught, 9 into 10 to the power 9 into Q1. Q1 means 1 coulomb into Q2. Q2 means this is the value 27 into 10 to the minus 8 into 10 to the minus 8. So this is 8 into 10 to the power minus 8 Q1 Q2 by R square. R square means this is the distance. There is 10 and 10, 20 centimeters. So 20 by 100. So 20 by 100 whole square. So 8 9 8 9 8 9 8 9 into 8. Now this is more simplest way, because here it is 2, so 2 square equal to cancel 8 this one, so it is meaningless to multiply it. 10 to the power minus 8 divided by 0 0 cancel each other, so 22 4 and 100, this is 100. So 9 into 8 into 10 to the power 9 into 10 to the power minus 8, 100 by 4, so 4 2 8. So 18 into 10 to the power of 3. So 18 into 10 to the power 3 Newton. So the first one is 9 into 10 to the power 3, and the second one is 18 into 10 to the power 3. So the third one is F3 equal to 9 18, so 9 27. So 27 into 10 to the power 3 and dot, that is so on. So up to 10. So if we add all the charges, that is F equal to the resultant force on that particular charge, 1 coulomb, due to this one, then this one, then this one, then this one, this all the forces you have to add. That is F1 plus F2 plus F3 plus dot plus F10. So the first one is, if we common 9 into 10 to the power 3, if we common 9 into 10 to the power 3, so the first one is 1 and the second is 2, because it is 18 into 10 to the power of 3, 18 into, and the third one is 27 into 10 to the 3. So 1 plus 2 plus 3 plus dot 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 up to 10. So if we add all the this value 1 plus 2 plus 3 dot 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 10, then we get 9 into 10 to the 3 into 10, n into n plus 1 by 2, n into n into n plus 1 by 2, so 55. So 9 into 10 to the 3 into 10 into 11 by 2. So this is the formula, n plus n into n plus 1 by 2, 1 plus 2 plus 3 dot 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 up to 10. You have to add all the numeric value. So this is 25, 9 is 20, sorry, 5 to the 55 into 10 to the 3 Newton, into 10 to the 3 Newton, and so into 10 to the 3 Newton. So the 20 number numericals is so if we multiplied it, then 4.95. if we multiplied it, this one 4.95 into 3 to the 5, this is Newton. 4.95 into 10 to the 5 Newton. So this is the answer, 4.95 into 10 to the 5 Newton. So all the numericals are completed. That is from here, it is from 16, 17, 18, 19, and then 20, and the next will be 21, 22, and so on. And there are total number of numericals. Here is 70, here is 75. So for the next classes I will try most of the numericals to be solved. So thank you, and don't forget to subscribe my channel to get a large number of series of numericals throughout the year. That is, I promised, I completed all the H.C. Verma numericals, and then Irodov, then DC Pandey, and for the middle of this session I think that I start a boost up session, and this boost up session is one day for one class, 1 or 2 numericals I think I solved, and all the numericals are most probably taken from NEET or the JEE Mains. So thank you for the day.